So our next talk is on vcpkg. So if you've never used vcpkg before or heard of it, it is a dependency or package manager for C++. If you've used Conan, then it's something kind of similar to Conan. There's some differences in implementation, but it's a similar kind of idea, managing your dependencies without having to do it manually. And our speaker for this is Augustin, who is on my team in the Visual C++ team. Augustin, welcome.
Hey, Sai, how's it going?
Yeah, pretty good. It's absolutely horrible here where I am in Scotland. I have like rain pattering on my window and it's cold and awful. I hope it's nicer in Seattle.
Yeah, it's been nicer lately, but we do get our usual 7 to 8 months of rain during the year. So
yeah, I always feel like, because I work with all of my team is in Redmond or Seattle and I'm in Scotland, although we're like pretty much on different sides of the world, I feel like there's a connection there by just how much rain both Seattle and Scotland have. But yeah, thank you very much for joining us today, and I'll hand it over to you.
All right. Thank you, everyone, for joining us for Pure Virtual C++ once again this year. What I will be talking to you about today is vcpkg, which is the C and C++ library manager tool that we have been working on. And specifically, I want to discuss some of the latest features that have been developed over the past year and where we are with them. I've got a few announcements to make as well. So let's go ahead and get started. So if you're not familiar with vcpkg, I will just do a quick intro. So vcpkg, as I said, it's a library manager tool. Another word I guess you could use is package manager. And its purpose is essentially to make it really, really easy to acquire C and C++ libraries. Now, in the past couple of years, there has been an ISO C++ developer survey that's been going out. And one of the questions there is essentially, what are your top pain points of C++? And if you look at the answers, you will see there's a few ones that you probably expect, things like long build times, for example. But consistently in the past few years, since the survey has started asking that question, we've seen that managing libraries has been consistently the #1 issue in terms of, like, if you look at people who strongly agree with it being a problem, that was always at the top. And this is a problem that has been going on for a very long time. vcpkg is designed to help solve that. So as it stands today, vcpkg has over 1,600 public libraries. These are like popular open source projects and also some of the smaller ones as well. I mean, it's a pretty large number, as you can see. You can install them for Windows, Mac OS, and Linux, assuming the libraries themselves actually support those platforms. The project itself is open source. You can find us on GitHub. We can feel free to fork it or add it as a Git submodule for your project or do whatever you want with it. Essentially, it's all out in the open. And we do get quite a lot of open source contributors as well. And we're very happy to receive their contributions and want to thank them for their ongoing support for the project. We really wouldn't have been able to grow as fast as we have without their support. And the way it kind of works is vcpkg is very CMake-centric in terms of things like authoring packages and getting things working behind the scenes. And it is written in C++ for C and C++ developers. And it is designed with both working in a local development environment and continuous integration in mind. So that's kind of a brief overview of vcpkg. And one line I wanted to throw in here, our goal with vcpkg is really for it to be the simplest solution for C and C++ dependency management. There are lots of different solutions out there. Some of them are solutions that individual organizations may develop. Some of them are actual package managers. Some of them are system package managers. But there's always some pros and cons to all the different options. With system package managers, for example, well, they're system specific, and you don't really have the same level of flexibility as you might have with a language package manager like vcpkg or Conan. And with some of the in-house solutions that different people and organizations come up with, and you have to worry about maintaining them. They're not always open source, so it's they don't get as many contributions. And overall, it just continues to be kind of an ongoing maintenance problem to deal with. So with vcpkg, it's a project that's out in the open. It's very active, and we're going in the direction of trying to really solve all the common problems that you run into when you're managing C and C++ dependencies. And specifically, if we're going to talk about what vcpkg can do for you, first of all, vcpkg builds libraries from source. This has been a defining characteristic for the product from the beginning. We often get asked, why don't we just provide pre-built binaries the way some other package managers like NuGet, for example, do? And the reason for that is that there are a lot of different ways you can actually build C and C++ libraries, and most of them will not work for your particular project. But that's actually not even the biggest problem. The biggest problem is when you're dealing with, let's say, a more complex dependency graph, and you have dependencies of dependencies, and some of those dependencies have shared dependencies upstream, and you have to deal with things like version conflicts. And how do you resolve that? Well, if library A depends on one version of Boost and library B depends on a different version of Boost, you have a problem, and that's something that you have to resolve. If you're not using a language package manager, you have to kind of resolve that yourself and figure out, okay, what version of Boost can I use? What version of these other libraries can I use? How do I install all the different libraries that I need in such a way that when I compile it all together and link them into my project, I don't have any problems. And this is the kind of headache that people run into, and one of the biggest reasons I think that people are saying dependency management is such a pain for C and C++. So vcpkg kind of solves that for you. The way it works with our big public catalog is all of these libraries are actually compiled together as part of a continuous integration process. In fact, anytime somebody wants to update the catalog by maybe introducing a new library or updating an existing library, what we do is we actually force the whole thing to build at once and make sure that all the libraries work together. And what this means is that if I say I want some 5 libraries out of the 1600, I can expect them to just work with each other out of the box without me having to do any additional configuration, without me having to change the way they are compiled or changing versions or fiddling with them and trying to solve different problems that would otherwise be coming up. And the way we describe this is the whole catalog is like a version set of all these libraries. Now, there is a downside to that, which is that you're not actually you don't have the flexibility of being able to say, I want this version of a particular library and this other version of a particular library. You kind of have to live with whatever vcpkg is currently providing, which is usually like the latest or closest to the latest acceptable version that compiles with everything else. But I will talk about more about that versioning problem shortly. But other things that you can do, so when you acquire dependencies, oftentimes dependencies have dependencies of their own, and sometimes those dependencies have their own dependencies, and you think you're going to install 3 dependencies and you end up installing 9 dependencies. And that's not, if you're doing this manually and building everything one at a time and going to individual GitHub repos to figure out the build instructions for each thing, seeing if it works for your build system, seeing if it works for your OS, that's not fun. Well, vcpkg solves all that for you. You can just tell it, okay, I want these 3 libraries, and then it will also install their own dependencies upstream so that although you just have to say you want those libraries, all of those like upstream ones also get set up for you, so it'll just work. And again, I talked about the version set thing, so the version conflicts, that whole thing is, that whole problem is avoided, which is really nice. And we have, in particular, some really good integration with MS Build and CMake build systems. Although you can use it with other build systems as well, but we do have some additional features that work for MS Build and CMake, and I'll be talking a little bit about that as well. And again, easy to use. This is the key. We want to make it extremely easy. When you go into, when you install a set of libraries, it's essentially as easy as going into the terminal and saying vcpkg install, and then you list a bunch of libraries. Maybe you might also specify how you want those libraries to be compiled if you want it to be something other than the default. So you might say, well, I want x64 Windows of this library, or here is a custom build configuration for something special that I made. You can create your own as well. So that's kind of how it all works. And this is kind of like the basics of using vcpkg. But we have been investing a lot into improving the tool. We've added a lot to it since we got started with the project back in 2016. Of course, the size of the catalog was the biggest, most obvious change over the years. But more recently, we kind of took a step back and thought, okay, we've been really increasing the size of that catalog. And at this point, we've covered many of the major libraries that people want. But are there features in the tool itself that we can add to make this to make the experience even better? And yes, the answer is absolutely we can. And I'm going to go through them right now. The first of these is something called binary caching. Binary caching solves one of the problems that may come up with the fact that your vcpkg builds libraries from source. So building libraries from source is good because it gives you the flexibility of building libraries in a way that actually work for you. So you're not downloading some random pre-built library that may or may not work depending on your particular build graph or whatever build configurations you require, whatever compiler flags and other stuff. So we want to be able to build from source at least once to be able to get that dependency graph set up nicely. And then once you have that, then you're good. Well, binary caching essentially allows you to do that exactly once and only once, unless you're making changes to the build requirements in the future. And essentially allows you to just cache those dependencies somewhere, or the binaries of those dependencies somewhere, and then be able to restore them as you need them. So the very first time you install a library of vcpkg, by default, right now in the tool, it will go through and build from source, and then it will cache them somewhere. And you can change the location where these binaries get cached. By default, it's going to be like on the same machine, but you can change that. So you could, for example, point to some file share or some other machine on your network, or some on-premises machine that in your organization that you have access to, and have all the caching going on there. Or you can cache it in one of the popular cloud storage solutions. So for example, you can use something like GitHub Packages to store your cache binaries. You can use Azure DevOps Artifacts. You can use Azure Blob Storage. You don't have to use Microsoft Cloud. You can use Google Cloud as well. And in fact, you can use any NuGet package feed, because we do support NuGet as a package format on the back end. So anything that acts as a NuGet package feed, you can use with binary caching. Now, this doesn't mean you can then pull those binaries and integrate them into some MS Build project, like by adding them as references in Visual Studio. That this is a different kind of NuGet integration that we're talking about. It's not using the NuGet tool itself. It's using vcpkg. But the package format is the same, which allows us to just be able to reuse those feeds without having to come up with completely new feeds that would support vcpkg. So that's kind of the thought process there. And the benefit of binary caching is, let's say you need to nuke your machine, start over. The second time you install everything, it happens in the span of a few seconds. It just downloads all the binaries and the sources. You no longer need to rebuild everything. Or say, for example, you want your development machine and your continuous integration environment to match. No problem. This is doable with binary caching. And you might have to go through the build from source once on your local development machine. Then when you switch to CI, assuming it knows about this backend, it'll just pull it from there. And anytime vcpkg is requesting to install packages, it will check the cache, see if valid packages already exist that match the build requirements that you have, and it will just restore those if possible. Otherwise, it will just update the cache with new packages that it builds on the fly at that moment. And so that's basically how binary caching works. And this feature has been around for a while, but I wanted to point it out as a nice way of saving you time, really, because time is the most precious resource in the world when it comes to dealing with C and C++ dependencies. And in fact, if we go to the ISO C++ surveys, I think the number 2 most common problem that people had was build times. So if you can build less frequently, that's probably a good thing. All right, so second feature is something called manifests. this is another feature I'm really excited about, and it also ties into the next two features I'll talk about, so that's why I want to talk about it now. Manifests are a way to declare your dependencies in a file. It's a JSON file. It's called vcpkg.json, and you can check that into your source control. So it's really easy to persist the state of what you want your dependency graph to look like for your project. Now, historically, the way you would install libraries with vcpkg, and this is something we now call classic mode. You can continue doing this, where we'll continue to support classic mode. We have nothing against it. It works great. But the problem with it is that you have to kind of go into the terminal and say things like, okay, vcpkg install boost and rapid JSON and OpenSSL and all these other things. And if you have to do that manually, that's not always fun, especially if you have to do it multiple times in different environments. Some people get around it by writing something like a shell script, which you can just run, and then it will go ahead and execute a bunch of vcpkg commands and set up an environment. But then you have to maintain that script. Somebody has to write the script. Manifests are a way of just bypassing that altogether. You just write your dependencies in the manifest and just let vcpkg go from there. You can actually just say vcpkg install with no other arguments, as long as you're in the folder which contains a manifest, and it will go ahead, it will read the manifest, and it will do everything to get everything set up at that point. Now, manifest mode does work a little bit differently than classic mode, in the sense that with classic mode, libraries get installed in a subfolder of the vcpkg installation directory. With manifest, they actually get installed in the subfolder of your project, wherever that vcpkg.json exists. In fact, there's a file, or sorry, a folder that's called vcpkg_installed, and under there you will find the sources and the binaries. That's where they'll go. So that allows you to kind of keep everything with your project, which is nice. So you have your manifest, which declares your dependencies, and you have your actual dependencies themselves, which live with your project. And I should call out that manifests work specifically for MS Build and CMake. We do want to continue expanding on the support, but those are the two environments the two build systems that we currently support. And in terms of using them with these build systems, with MS Build, you really just have to turn on the project property for using vcpkg manifests. And then once you've done that, it will just work. Whenever you do a build in MS Build, it will actually first check with vcpkg if any packages need to be restored. It will go ahead and do that, and then it will go ahead and build your actual project. With CMake, it's also pretty straightforward. So as a general rule, in general, when you're using vcpkg with CMake, there's a CMake toolchain file that we provide with vcpkg. You have to make sure you link that into your CMake. And as long as you've done that, then it's simply a matter of being able to just reference the individual packages in your CMake list.txt files. Usually that's just saying find package and then the name of it. And then you have a target link libraries function as well, and list your libraries there. Some libraries might not necessarily support CMake, and then you might have another extra step, or maybe you have to point to like the include paths and where the libraries are, but it's really just like adding an extra line or two. But basically what I'm trying to say here is we're just using existing CMake mechanisms for finding stuff, and then it should just work. And the benefit then is once you have this set up with CMake, when you run CMake configure to generate the cache, it will invoke vcpkg. It will basically run vcpkg install with no parameters. So it will look at the vcpkg.json and just set everything up. So that's basically how that works. Since vcpkg.json is something you can easily check into your source control, it makes it really easy to maintain consistency across your development team, making sure everybody installs the correct things. You can specify what you want and persist it in a way so that you don't have people installing the wrong dependencies. And you don't have inconsistencies as well between your development environment and your continuous integration environment, because you presumably want consistent reproducible builds. And this was a way to ensure that. One other thing I want to call out about vcpkg.json, if you are contributing to the vcpkg project, you will care about vcpkg.json as well, because in fact, This is used to specify metadata about libraries that will be consumed with vcpkg. So we have something called a control file that we've used in the past. This is now deprecated. We're using vcpkg.json to also like identify libraries that will be part of the vcpkg catalog. So just to identify things like, okay, what dependencies do those libraries have? And so that this is just information that vcpkg can then leverage by consumers of vcpkg. So it has all the information about all the libraries and the overall build graph. So I'm not going to go too much into that, but that's something you can find out more about if you go through our documentation. And this is just a basic example of what a vcpkg.json file looks like. There's a name kind of for the project that corresponds to this vcpkg.json. So that's the project you're specifically working in, and as well as a version for it. Version string is actually mostly used. You can basically put anything you want if you're consuming libraries of vcpkg, but if you're producing libraries, then that was actually like the version for the library you're producing. And then what are the dependencies that you need? So you basically just list all the libraries you care about, and you're good to go. That's it. It's like running vcpkg install, cxx, opts, fmt, and range v3, but this is just specified in that file. Okay, and then if you have like if you're doing it on CMake, again, CMake list.txt, you can just say find package for all the different packages, and you have a target link libraries line at the bottom as well, which sets everything up. And then everything should just work. You run CMake configure, it invokes vcpkg behind the scenes. You don't have to do any additional work. vcpkg will be active and being used as needed to restore your dependencies. Okay, so now for the first announcement of this talk. So we had another feature that was experimental called versioning. And we're happy to announce that this feature is now generally available. We're considered to have moved out of experimental state. So we're very excited about that. This is one of the most popular features we've been requested over the past couple of years. What this lets you do is to lock down on your preferred library versions. So remember when I said that vcpkg, the catalog exists as one version set, and the downside is you can't really pick and choose your own versions? Well, actually, I lied. You can. You can use the versioning feature to do that. So by default, if you do nothing, you will still just get whatever version is in that version set, but you absolutely can declare your own versions. So you do this in the vcpkg.json file. It only works with manifest mode. And there are three configurations you can make, I guess, as part of that. And I'm just going to quickly call them out. The first is something called built-in baseline. This basically establishes a default version for all the public dependencies. Think of this as the version set that you're starting off with, right? So if you're not using versioning, this will just be like whatever the most recent, whatever version of vcpkg you currently have installed on your machine. It will just be using everything from there in that version set. But you can set this to something else. The second thing you can set is something called a minimum version. So this is useful if you want to say, well, actually, I want a greater version than my baseline. I don't want to be just on the baseline. So if you want to say, okay, I want at least this version of library, you would say, you would use version greater than or equals to say that you want that. And what this will do is it will typically give you exactly that version that you asked for, but it may go a little bit higher if vcpkg detects that actually your build will not work because there's some incompatibility based on the version you picked and what your overall build graph looks like. If that is the case, then it will increment that and it will go to the next higher minor version that it can successfully build. And that's basically how that works. So it's kind of like saying, I want this version, but I'm flexible. Like if you need to go a little bit higher, you can do that. But sometimes you might really say, no, you really need to use this specific version. Don't change it. Do exactly what I tell you. And that's where overrides comes in. So that lets you essentially say, I want exactly these versions of these libraries. And you can use that. This is particularly useful when you want something that's really like an older version. Then even the baseline overrides trumps everything. If you say that you want that, that's what you get. So that's basically how versioning works. This is an example of vcpkg.json file. It looks essentially the same, except you can see we have version greater than or equals for FMT. So we're saying we want at least that version. We'll typically get that version unless it won't build, and then it might give me like 7.1.4 if that exists. And then zlib is not doesn't have a version specified, which means that I'm just going to get whatever the default is in that baseline. So you don't have to specify versions for every single dependency, but you do need to specify that built-in baseline so that we know exactly, like, okay, what is your default state? All right, so that's versioning. So then let's talk a little bit about registries. So registry is another feature. It was experimental. It's now generally available. We're really excited about that. This allows you to bring your own libraries to vcpkg. This is a big deal. So vcpkg has this public catalog over 1,600 libraries, but you can actually bring your own libraries. Or maybe you can have like a custom fork of an open source library because you don't want the default one. Maybe you have some additional security checks that you need to do. Maybe you did some patching and yet that hasn't been pushed upstream yet. Or you just have your own completely private library, completely isolated from the internet or from the open source world anyway, that maybe you're using within your organization. That's where you can use registries to help you. So there's a couple different configuration files that you can use to set up a registry, but essentially the way this works is it's like setting up your own vcpkg catalog. Okay, you have a baseline that you can set up. You can define your libraries and the versions. You have a portfile.cmake, which is basically your build recipe. This is if you've authored libraries for vcpkg, this is essentially the same thing. And you can specify, okay, what is the type of registry? Is it like a file system registry, or is it something that lives in a Git repo somewhere? Where does the registry exist, and what are the available packages? You still need to use vcpkg manifest with this, or vcpkg.json. When you're producing libraries for, remember when I said when you produce libraries for vcpkg, you still need vcpkg.json for that. You also need that when you're authoring libraries for registries. So that's basically how that works. And that file, or one of the files used for registries is vcpkg configuration.json. So I wanted to call this one out because it's a bit different than stuff we've talked about before. So in this case, here we have a registry. It's a Git registry. So there's actually like a Git repo that you can specify that's under the repository section. Then you can list the packages that correspond to that. So that's basically how that works. All right. So I wanted to say a few things just in general about vcpkg. So vcpkg is an interesting case of a Microsoft product that from the beginning has been great for open source projects. Like if you have an open source project and you're using and you're consuming dependencies, vcpkg is a great tool for that. And that has been the case from the beginning. What we haven't heard so much is vcpkg being great for enterprises, which is really weird because we're Microsoft, so we're kind of expecting it to be backwards, right? Like, oh, we're great at targeting enterprise, but open source, I don't know. Can we do that? Can we make it work for open source? But since this started off as an open source project and we've been investing so much into it, I think the perception from the beginning in the community has been, oh, if you have an open source project, yeah, you should use vcpkg. So that continues to be the case. We'll continue keeping vcpkg as a simple solution for C and C++ dependency management with a lot of powerful features. It's also the case, if you're working on small projects, yeah, vcpkg is great for that. Even if you only need, a couple of dependencies, just being able to save time on building those dependencies yourself, that's worth it. At any time you can save, it's absolutely worth it. But it's also the case that vcpkg is great for education. I know that we have some students that for their coursework, they're required to not use any libraries because using libraries is cheating. You have to write all the code yourself from scratch. We don't really think this is the best model, and it doesn't really apply to the real world when you go and get a job as a developer. So hopefully we do see more students using dependencies to save a little bit of time and not rewrite things that have already been written many times by people in the past. But vcpkg is a great tool for saving time. And we know if you're a student, you're really busy, and you want to save time on that, on setting everything up. So that's great. But we also want to say that with these 4 features we've added, vcpkg is great for professional development. It's great for enterprise developers. That is a statement we want to be able to make. We know that all 4 of these features that I've talked about have been popular requests by people from all across the community, even for open source projects and for small projects. But there are a lot of professional developers that have told us, we cannot even start thinking about using vcpkg until you have these features. Well, now we do have these features, so we want to be able to say, give vcpkg a second look. Try it out. Let us know. Is this something that works for you? And we're happy to make it better if it's not. But we are really excited with all the progress we've made, and we do think we have a pretty compelling solution now to managing your dependency needs. whether you want to lock down on versions, whether you want to declare stuff in a manifest, whether you want to save time with builds. vcpkg is a great tool. And last but not least, we now finally have a vcpkg website. I'm really excited to announce vcpkg.io. For a long time, we've just been like a repo on GitHub. We started off with a small team just working on this as a tool for migrating people to newer versions of Visual Studio, and we've grown way, way past that scale. We're targeting 3 platforms. We have over 1,600 libraries that we support. And of course, we have these features now that really give you a more compelling solution for controlling your dependencies and setting up your environment the way you want to. But we also thought, you know what, we need a website. I mean, everybody needs a website, right? So please check out vcpkg.io, whether you're new to vcpkg or whether you're a vcpkg veteran. We have a number of useful things on the website. You can learn about vcpkg, of course. You can follow the getting started instructions. We have our documentation there as well. You can actually, let me actually just switch to it. So this is what the website looks like. Again, it's live right now. I want to specifically call out the packages page. Okay, you can actually browse for packages. So you can actually say, you know, does vcpkg have the libraries that I care about in the public catalog? Well, now you can search. You can just go ahead and look for stuff, and you can see exactly what is available. So that's something that that can be pretty useful. Like I'm going to use SQLite as an example. You know, we have a couple of different options for SQLite. You might be curious to know what are the options that are available. And if you want to see, okay, how do I actually install this? Well, assuming you're using classic mode, you know, you can just copy and paste this from here. So it's very, very straightforward. Do check out our website and let us know what you think. All right, so that's basically it for this talk. Again, if you want to get started with vcpkg, check out vcpkg.io, which is now live. We are always looking for feedback. If you try out vcpkg and you find something that doesn't work very well for you, please feel free to interact with us on GitHub. You can file an issue if you find like a bug or something that's just broken, or if you want to have new libraries added to the ecosystem, at least to the public catalog. Of course, you can always add your own to a private registry if you want. Please go ahead and do that. We also have a discussion forum now on our GitHub repo. So if you want just general discussion about vcpkg, or if you're stuck, you have questions, please feel free to engage with us there. We're happy to have you. And well, again, I want to thank the vcpkg community that has contributed so much to this project and made all of this possible. Thank you.
Thanks so much, Augustin. Okay, we've got a bunch of questions in chat. If you have any other questions and you're watching on Twitch or on YouTube, please head over to Microsoft Learn TV, which is where you can ask your questions. If you ask questions somewhere else, we won't see them and they won't get answered. So if you want questions answered, go to Learn TV. Okay, so one question is, will vcpkg be distributed as part of our next, as part of VS 2022?
So yes, we are actually working on shipping vcpkg as a binary that can be distributed with Visual Studio as well as Visual Studio Code. We do expect that to land in the Visual Studio 2022. We've done kind of the groundwork for being able to ship it as a binary. There's a bunch of like security stuff and compliance stuff that we have to do. And right now, for those who don't know, the way you install vcpkg is you have to clone the repo and then you run the bootstrapping script we provide to build it. But by being able to distribute it directly as a binary that you can easily download it and get started with, this enables us to integrate it with other environments. So we absolutely will be shipping it with Visual Studio. It'll be included if you're using a C++ workload, a Visual Studio Code. Right now, we're thinking we'll probably have like a separate extension you can install for vcpkg. But yeah, we are absolutely doing that.
Cool. Before I go into the other questions, if you're on Learn TV and you go into the announcements section, you'll see the resources which Augustin just posted. Another question is there any plan for vcpkg to use custom private repos? I think we answered that with our with the talk already. But then there's another question down below, which is, can versioning be used for public libraries, such as for installing a specific boost version? I think that's something you covered in the talk as well, right?
Yeah, so versioning does work with that. You may not be able to get every single old version of a library. If you need something that's not already currently available in the catalog, you may have to set up a custom registry for it. But going forward, we are expecting that every library that is updated, you'll be able to install any of the previous versions. So you don't have to worry about. This was another problem people had with vcpkg, was we would update the versions, but people really wanted to stay on the old version, and then they updated vcpkg, and now it's like updating their version. So with versioning, you don't have to worry about that. Yeah, you'd be able to stick to that version. The worst case, if a particular version is not currently provided there, you can set it up in a custom registry.
How about installing an older version through the command line instead of via vcpackage.json?
We do not currently have support for that. If you feel really strongly about that as a feature, please feel free to start a discussion thread with us on GitHub. We would love to hear your feedback. We just prioritized vcpackage.json because we kind of saw that as the future of just managing dependencies with vcpackage. There are a lot of benefits to using vcpackage.json, but we do understand, of course, that the classic mode has been around for a while. We will continue, of course, to support it. So yeah, please let us know, and we can have that conversation.
Cool. And then on the other side of newer versions, what if there's some like publicly available new version, like OpenSSL gets an update, but the vcpackage public repo hasn't been updated to pull down the most recent version which is available? Do we have something to help out in that scenario?
Yeah, so again, that's something you can set up with a custom registry. So we do have a pretty active repo. We do get a lot of PRs with updates to libraries. So hopefully we don't get too out of date for too long with anything. But if you do really badly need the latest version of a library and it's not currently in vcpackage, you can always set it up with a registry. Again, like a lot of these features have been set up with flexibility in mind. We recognize that the default experience, if you do nothing, might not be flexible enough. Maybe you need to make some changes. With things like registries and versioning, you can go in and customize your requirements as much as you want.
Cool. And then there's a question about automating patching. Like if you have some custom patches that you want to apply, but don't necessarily want to like have your own fork of the library. What's the story with vcpackage there?
So really, like your options are, if it's like an open source library, you can contribute to the vcpackage public catalog, and then you can make use of that, and then everybody else in the community can make use of that. Or you can set up your own registry, which would require doing the additional legwork of figuring out, okay, how do we actually compile this library and listing it out and listing the available versions and stuff like that. Those are the current options that are available. We don't really have anything that's in between that. Again, if you have any suggestions for us on how we could improve the experience, please start a discussion with us about it.
Cool. And then this question on maintaining in-house patches for public libraries. I feel like we've covered that with these answers so far.
Yeah, like a lot of the answers, I think, come back to registries. I will also call out that we are actually working on something like this. So we're actually working on rolling out vcpackage across Microsoft. When I say vcpackage is enterprise ready, I'm not just saying that for the sake of some marketing messages. We are actually working with a lot of teams across Microsoft to set something up. And one of the workflows we will have is they're not going to be pulling dependencies directly from the public catalog. They will have like a mirror of it that's controlled and has custom patches and security patches and stuff like that, and security checks, and passes all the compliance requirements. And that also has like business continuity in case the developer behind an open source package removes it one day. You don't want everything to just break. So that's a workflow that's being set up using vcpackage, using versioning, using registries to control the environment.
Cool. So next is CMake a requirement to create VC packages?
Yes. So that's just the workflow that exists today. It is CMake based. That was just a design decision that was made since CMake is very popular in C++. I know Conan, I think, is more Python based, although I'm certainly not an expert on Conan. So Conan and vcpkg are kind of the most popular options available today. So yeah, if you want to author packages, then you would have to do it through a CMake way for vcpkg, and that's what we support today. Again, if you have suggestions for us on alternative ways we could do it, please feel free to start a discussion thread.
Right, but your project build system internally isn't required to be CMake. Like, you can trigger off some other build system internally.
Yeah. So to be clear, I'm talking about producing libraries with use for vcpkg. If you're consuming libraries, no, you do not have to be using CMake.
Yeah. Can we talk about automated port publishing for libraries which are published via vcpkg? Things like automated pull requests for opening new tagged versions in GitHub.
That is a great suggestion, and it is something we've talked about a little bit in the past. We've been thinking about things like using GitHub Actions to automate some of this. We're still in early stages exploring what we could do. We definitely want to continue improving the process for updating ports. We know we receive a very large volume of PRs, and we spend a lot of time processing all those PRs. So it certainly benefits us as well to be able to automate as much of it as possible. So we're continuing to work on our CI process and our automation process. And just stay tuned. I guess you should see improvements gradually over time.
Great. All right. Well, we're pretty much exactly at time now. So thank you so much, Augustin, for your time and for this talk. I hope you all learned something new about vcpkg and how that can help you out. So see you later, Augustin.
Thanks for having me.